we're going to analyze the building with the schematic view. So the schematic view, it's something that it looks like the building. We have 2 floors and a basement. And but here we should have all the components for the HVAC system, heating, cooling, and ventilation system. So far, we are dealing just with the air handling unit. And now I'm not drawing the supply and the return ducts. I'm just working today with the air handling unit and the cooling energy that comes from the air-cooled chiller, and then the heating energy that comes from the condenser boiler. So a condenser boiler, it's something that usually condenser boilers are on the basement, and air-cooled chillers are usually on the roof. Okay, and then we have to connect the condenser boiler to the heating coil and the air-cooled chiller to the cooling coil. If you see, when we have for both systems, we have supply, water supply, and then water return. So technical plans usually are printed in black and white. So we cannot have red colors for the heating, blue colors for cooling. It doesn't work because we work with copies or black and white plans. So one way to differentiate between the supply and return is using the dashed lines. Okay, so usually we have the continuous line for supply and the dashed line for return. So in both systems, we have the air-cooled, supply continuous, return dashed line. And here supply continuous and return dashed line. In this, in the heating system, we will start with the heating system. We have the condenser boiler. The condenser boiler, it's a box. We have the outlet, so the pipe that goes from the condenser boiler to the heating coil. And then we have the inlet, the pipe that goes from the heating coil to the condenser boiler. We need a circulation pump. Okay, so in the supply, we need to pump the water up because we have to go from the basement to the roof. So we need this circulation pump, and we need at least an expansion tank. Okay, so the expansion tank, we will heat up the water will expand, and then if we don't have the expansion tank, then the pipe will burst. Okay, so we need this expansion tank. So on our mechanical room, we need the condenser boiler, the expansion tank, and the circulation water pump. And then the boiler, it's something that burns gas, and it generates, well, this gas that we don't want to breathe because it's poisonous, and then we have to get rid of it through a chimney. And that chimney should be vertical. We cannot have a horizontal chimney. For example, people, well, students, they always ask, can we do something like this? Can we get rid of the exhaust air through a window? No, we can't. This is forbidden. And why is it? Because people walking on the street, you are forcing them to breathe the exhaust gas, this poisonous gas that comes from the boiler. Okay, so this can't happen. You can't have these kind of gases in contact with human beings. Okay, so don't do this. Extend this all the way up, and the distance or the height of this chimney should be more than the height of a human being. Okay, so if we have a human being here, this chimney has to go beyond this level. So at least this should be like 7 feet. We have to extend the chimney like 7 feet above the roof level. That's the safest thing we can do. Even if this roof is not accessible, but people with maintenance, they can be here and they can be breathing the air that comes from the exhaust gas. Okay, so that's important, and keep that in mind, that in our beautiful building with a beautiful render, there will be chimneys expelling gases. If we use the condenser boiler, if you go electric, you don't have any chimney in the building, but well, we do have chimneys because if we have a toilet, okay, if we have toilets, we need an exhaust system from these toilets. So I think I have to leave the boiler. It should be here. So we need something that extracts the air from the bathrooms or the restrooms where the toilets are. Okay, so at the end, we will always have some chimney going through the roof. And again, the height of this chimney should be the same as this one, so at, around 7 feet, because we don't want to breathe the air that comes from the toilets. Makes sense. Okay, so at the end, on this roof, we will have chimneys. We have vertical ducts that get rid of the air that we don't want to breathe inside the building, but we don't want our neighbors to breathe that air. So that's why we need to, and even if we have taller buildings around our building, we need to increase the height of this chimney. Yep. But we will deal with this in the following weeks with all the exhaust pipes and all the water supply pipes that we need for toilets, sinks, and showers, or whatever. But so far, that's what we need today. And this pipe that goes out of the building, we have to reduce the size of the horizontal pipes. Okay, so it should be vertical. So we have to place this close to a shaft, so we minimize the horizontal part of this exhaust air duct. Okay, so though we have all those constraints, so when we are analyzing the building, we have to keep that in mind. This is what we need, and now we look at our building and we see what we have to do. Okay, so if we analyze this building, you see that we have different shafts here. We have shafts here in the classrooms. We have a shaft here where the supply duct is close to the air handling unit. Well, we placed the air handling unit close to this shaft to minimize the supply duct here. It goes immediately into the building. And we have another shaft here, and probably this shaft is the right one for the exhaust pipe that comes from the boiler. Okay, so I think we're going to place this on the basement close to this shaft. So we will place that's the first decision that we have to make. Where do we place the condenser boiler? So it's going to be on the basement close to this shaft, and then we will get rid of the smoke or the gases right away. Okay, so let's do it. We have to go to level -15. I can see this because in the view range, okay, because I need to have an idea. So this is the air handling unit, and the shaft was here. And if you don't want to see this, you have to go with the view range. You have to work with the view range. I make this unlimited at the top. If you associate this to level 15, you don't see anything. Okay, but well, sometimes we need to see what we have above or what we have below. So that's why we use the view range. But anyway, we're on level -15. That's the basement. And now we have to insert the condenser gas boiler. So if you analyze in systems the mechanical equipment that we have here, so look at this. We have condensing boilers at the top. Okay, so we have condensing boilers, then we have condensing unit. This is air cooled. Okay, so we can use this for the air cooled chiller. We have cooling towers. We will use this today as well. We have a heat pump. We're not going to use this today, but we will use heat pumps with split systems next week. We have the inline pump. This inline pump is the water pump that we need to move the water from the boiler to the air handling unit. Those are the air handling units. That's another pump here, so we can use either this one or that one. We have radiators. Next week, we will use radiators. We have the water-cooled chiller, so we will use this today. And here we have air-cooled chillers. Okay, so that's the one that we're going to use. And here we have storage tanks, terminal units. I think this is the VAV system, variable air volume. So at some point, we will have to insert those in our ductwork. If we have time, we will try to do this today. And finally, we have a water heater. So water heater is not the same as a water tank or the storage tank. They are two different things. Okay, the water heater is for domestic hot water. So when we design the water supply, the cold and hot water supply, we will use water heaters. And then we have this WSHP. This is a heat pump, but I don't know what this is. So we're not going to use this one. Okay, but we are going to be using most of these elements that we have here. Today, we start with the condensing boiler. So this number depends on the size. Well, it depends on the power, but the power affects the size. So in this small building, we're going to use the 301, okay? And we're going to place it here in the basement. Okay, so this is it. And now we have to analyze what we have here. This out is duct. So that's the chimney. It goes this way. And if you see, if we have a square with lines, well, that means that this is an air duct. This is not air, it's a gas, but it's not water. When we have water, we have this closed loop with a pump. You see, well, the symbol here is very small, but it's a closed loop with a pump. Something like okay, so this symbol, that means that it's water and it's a closed circuit. Well, it can be water or any other, it can be the refrigerant fluid as well, but it's a closed circuit. So this is the outlet. Okay, so this is the outlet of the boiler. We have to connect this to the inlet of the air handling unit. And here we have an inlet. And then we have to connect this to the outlet of the air handling unit. Okay, but first, if we, okay, so now we have our this one here. Well, if you look at this as a transparent hidden line, no, wireframe. Well, the mechanical room, it's here. Okay, so we will place the pump here. And you see that this is the outlet, this is the exhaust pipe, and this is our shaft. So the first thing I'm going to do is to rotate this way so that we immediately get to the shaft and go up. Okay, so we minimize the horizontal part of these pipes. So on this view, what do we have to do? We have to go this way and then go up with the pipe. So I'm going to select this, draw duct. In well, in 3D view, it doesn't work well, especially when you have these front views. I'm going to draw the duct. Okay, so now it works here. And I want to go up, okay, because I have the shaft here and I want to go up. To go up, I have to change the elevation. So the elevation is 4 feet. And if I want to go up, I have to change this to, let's say, 100. And you see that we have a vertical duct. And then we need another horizontal, and we can escape. And we have this. It's too high, so I need to get rid of the horizontal part, and then I can drag this down. Okay, and this should be at least 7 feet. The distance between the top of the chimney up to the roof level. And now I have to make sure that the pipe is inside the shaft. Probably it's not, so I'll move it here. So on level 30, yeah, you see how this pipe is within the shaft. Yes. If we look at the model, we have this condenser boiler and the chimney, and we get rid of the air, the gas. And now we have to connect the boiler to the air handling unit. And well, if you work with the wire frame, it's a mess. If you work with the hidden line, it's slightly better. But even when you have all the ductwork here, the supply, the return, I recommend you hide it to work with the pipes. That's risky because one of the goals is to avoid conflicts between pipes and ducts. Okay, so at the end, we will have to activate everything. And but so far, we're going to hide in view category. So I'm going to hide all these and the diffusers and the flex ducts. Don't delete it, just hide it. Okay, so now we have it. Oh, what's the problem? I have already done, yeah, because the duct here belongs to that category that I have hidden, but I'm done with the exhaust duct. It's there, so I can hide it. Okay, so I don't need to see it because I have already done it. And now I want to work with the pipes. So again, let's analyze this. So we have two closed loops, this one and that one. Well, actually, there are different loops here. Oh, I did something wrong in the previous section, so it's good that I'm recording this. Because look at this. Here we have a black closed loop, and here we have the blue and the red. So this is the inlet, and that's the outlet. Okay. So that means that we are connecting this inlet to the air handling unit outlet and this outlet to the air handling unit inlet. And now here we have different options. So I can go through this shaft I have here. And then I can go all the way to the air handling unit. I wouldn't do that because another rule of thumb when we are designing pipes and ducts is to minimize the amount of pipes or ducts that we have outdoors. Okay, so because having all these pipes outdoors, we're wasting a lot of, we're spending a lot of money and energy on heating up the water. And suddenly, if it goes through this, if it goes inside the building, it's good because it doesn't lose the heat. But the moment we run this duct outdoors, we're losing a lot of heat, heat that we have. Yeah, we have spent money and energy on heating up this water, and suddenly it's out of the building and it's losing all that heat until it gets to the air handling unit. So we don't want that. And for sure, we need to use thermal insulation, but the fewer pipes outdoors, the better. So what I'm going to do is to go up, and then I'm going to go through the ceiling until this shaft, and then from this shaft, I will go to the air handling unit because it's very close. Okay, so here I minimize the amount of pipes that go outdoors. Okay, let's do it, and probably by doing it, we will understand it better. So here we have two pipes. We have this black one. This is another closed loop, but I don't know. Okay, I don't know. But I think those are the right pipes that we have to connect to the air handling unit. So let's start with the outlet. So draw pipe here, and I want to go up to the false ceiling. So I have to change the elevation, but I will change the elevation to 10. See what happens, and then I will go horizontally that way. So let me see what I have done. Okay, it can be higher, closer to the ceiling, something like that. And then I have to go all the way to the shaft. So the shaft should be here, kind of. Okay, too long. And now I have to go within the shaft. And now I'll change the elevation. So I have to get out of the building. So I change the elevation to, I don't know, 50. I don't know if it's enough. Now I have this horizontal pipe here. So let's see. Okay, probably 50 is too much. Because now I don't remember. I have connected. Okay, so this is the outlet. Okay, so I have to connect this to the air handling unit inlet. But this is the boiler. So I have to connect this to the heating coil of the air handling unit. What is the heating coil? We have two coils here. This one and that one. Okay, so here you see that we have another closed loop. So this is one of them is the heating and the other one is the cooling coil. What's the cooling coil? The cooling coil is the one that has a drainage. Okay, so you see that here we have the symbol. This is the drainage. So the drainage is to get rid of the water that condensates inside the air handling unit. But that happens in the cooling coil. So if this has a drainage, this is the cooling coil. If it doesn't have a drainage, this is the heating coil. And we are, okay, so we have to connect this to the inlet because that was the outlet of the boiler. So I have to connect outlet to inlet. So I have to lower this pipe. Here. And then I'll go this way. And now from this is the inlet. Draw pipe this way. And now from the top view, if you connect both, there you go. Okay. So remember, select this outlet, and this should be inlet in the air handling unit. So what have we done? In this schematic view, we have done this. circuit. Okay, so the one, this is the outlet of the condenser boiler, and then we go to the inlet in the air handling unit. I'm going to do the other one, and then if you have any issues, I'll be. Okay, so this is the outlet, and now this is the inlet. So I have to draw a pipe here. And now we have to go up and make sure that you rotate the views so that we don't have any intersections here. So now from this one, I can go up, draw pipe by changing the elevation, 10, and then I want to go horizontally. Just a minute, I'll finish this and I'll be. Okay, so this is it, and I'll move it up. So make sure that these two pipes are at different levels, and then we won't have any intersections between them. See, draw pipe. Now I'm inside the shaft. Change the elevation and go horizontally. And now on that view, I need to adjust the height because now I want to connect this one. Okay, so this is the inlet and this is the outlet of the heating coil. So I want to connect this pipe to this one. If I make sure that the elevations are matching, then from this, go 5, then on the top view, so that's the problem here. Go. That. Okay. We have the same, the first circuit. This is connected to this, and then the outlet of the heating coil is connected to the inlet of the boiler. Well, outlet, inlet, inlet. So they are both correct. So in this schematic view, we have done the red ones. Okay, so we have connected the condenser boiler to the heating coil to the supply and the return. But as you can see here, we have two different elements. We have the expansion tank and we have the circulating pump or the water pump. So now we have to insert these two elements here. So the circulation pump, we have to connect it to the outlet circuit of the condenser boiler. So this is outlet, the one here, and this is inlet. So we have to connect the circulation pump there. We can go to systems, mechanical equipment, and here we have the pump. We have this inline pump. We have the 1.5 inch or the 2 inch one. it's a question of size. In this small building, use always the smallest option that we have here, this 1.5 inch. We can use it, and it has to be connected there. Probably this pipe is too short. Yes, I think it's too short. So we have to move the boiler like this. Okay, because that pipe was too short. So I'll try again. Equipment, inline pump, 1.5 inches, and now here it works. We have this inline pump where the outlet of the air handling unit of the condenser boiler is. Okay, so that's the outlet, and we have to move this water all the way up. The same thing we have here. Outlet, water pump, up. So if we want to find an expansion tank, and if we don't have it as an option in REVIT, I have to find a website with expansion tanks, and there are a lot of websites. In this and the other section, I found this one. This is MEP Content in Trimble. So Trimble is the company that develops the SketchUp, and apparently they develop things for REVIT too. Well, this is building information modeling. So they create families for free so that we can download them. Okay? But if you type MEP expansion tank for REVIT, here you will find MEP content, download, yeah. So free REVIT families. So if you click on any of those websites, you can find what we have here. The thing is that we have a lot of, we have expansion vessel or expansion tank. Here we have another one, expansion vessel. Well, in the other section, we found out that there are two different kinds of expansion vessels or tanks. We have this one and that one. This has an inlet and outlet, and this has only one inlet. It doesn't matter. I selected either this or this because they look the smallest one. So we are in a small building. So I'm going to download this one, or I'm going to download the other one. So if you download, probably you will have to register. If you have a, do you have an account in Trimble? You should, because I will sign out. Okay, here in this website, you have a lot of things. You have heat pumps, you have a lot of things. Okay, chillers, fans, ventilation issue. You have a lot of things. So if we find the expansion, or you look for expansion vessel, here we have this. And if I want to download this one, I have signed out, but okay. I select this one, the RFA, that means REVIT family. This is what we need. If you download, you have to sign in with your email. And I do have a password. Okay, so if you're a Kim State College student, this is for free. If you don't have an account yet, you can create your own account, but it's for free. Okay, and once you are signed in, you can start downloading the element. Okay, so if you download the element, it's here in downloads. And to insert this on your REVIT file, you only have to drag here, drop, and it's there. Now I have two kinds of expansion vessels, the one I inserted for the last session. Anyway, just in case, I'm going to make sure that I upload this on Canvas. Okay, here I have a module with REVIT templates. So everything that is a template or the REVIT files, I'm going to upload here the expansion vessel, then expansion vessel. Okay, so if you don't find or if you don't have an account, you can import this. You have to download it and then drag and drop in your REVIT file. But if you get stuck because you I want this family and I don't find this family in REVIT, so go to one of these websites and open an account, create an account, and you can download all these bin files for free. Okay, so there are thousands of them, and people are willing to give away this information. So you can download anything, and you can search what you're looking for, and that's it. Okay, so we're done with this, and now we have to insert one of the vessels. Okay, so but when you drag and drop, it's not in systems. If you go to systems, mechanical equipment, you don't find the vessel there. It's in architecture component, place a component, and you have the vessels that you have inserted there. Okay, so it's not a I don't know why, but it's not a mechanical equipment, so it's here that it works. So either way, I'm going to insert this one that it's more complicated than the other one. So I'm going to insert this, and well, let's insert this somewhere. Yes. Let me insert this one, and I'll be with you right away. Okay, when you insert this, you see that it requires a host, and the host is this, but I don't want to do it. Okay, so make sure that it's now it's not attached, because I want to do something different with this vessel. Okay, so where do we have to place the expansion tank? There's I don't know, usually I would place the expansion tank on the supply, but the more schematic views or schematic systems I find, I think most of them are connected to the return. Okay, so let's do it. Let's connect it to the return. And well, but if we analyze this, in this case, you see that we have an inlet here and we have an outlet here. What is an expansion tank? When there's an extra pressure on this pipe, it can be vertical or horizontal, it doesn't matter. So when we heat up the water expands. Okay, and it wants to
My expansion is in a different or the different, I don't know, it opened a different REVIT folder.
I'll be with you right away. I'm going to explain this. We have an expansion tank that has a outlet, and in this case, it has the inlet. Okay. So what we have to do is to connect this, and then this. And if the water expands, this part of the water that we don't need is released to this water tank. And then when the water shrinks, because if we pull down, so the water gets to the original size, then it requires to go back to the circle. Okay, so that's why we have to connect the inlet and the outlet to the same pipe. In other cases, when we have an expansion tank with only one inlet, and this is the pipe. So there's a valve here, and when we need to release the water from the main circuit, we release the water into the expansion tank, and then when there is a sensor, and when we need this water again, it goes back through the same pipe. Okay, so there are two different kinds of expansion tanks. We don't know. We are not experts on expansion tanks, but in this case, here we have we have the inlet and outlet, and in the other version of the expansion tank, in this one, in this version, okay, as you can see here, we just have the inlet. And I think this is upside down. Either way works. We're going to use this because it seems a little more complicated, but we can work with both of them. So do you get the expansion tank here connected to the same vertical pipe? Inlet and outlet. We are done with the heating system. Boiler, we have the chimney. By the way, I hope I don't have any conflicts between my pipe and my new, no. Apparently, there are no conflicts between the exhaust pipe and the new tank. Okay, but even if you hide it, unhide it, every time you do something different, unhide it and make sure that what you have done, there is no, it doesn't conflict with the elements that you already have there. So that's the heating system. And now we have to work with the cooling system. So there are two options for the cooling system. In the other section, we did this. So you have to watch two videos, this section and the other one, but the other one is just how to connect the air-cooled chiller to the cooling coil. But in this section, we're going to do this. So we're going to place the water-cooled chiller on the basement, the cooling tower on the roof. We have to connect the water-cooled chiller to the cooling tower, and then the water-cooled chiller to the cooling coil. Okay, so it's more complicated. I told you on Tuesday that this system is more efficient, more expensive, but for big buildings, probably this is better than the other one. If in a middle size commercial building, I would do this. Okay, but we're going to do both, and you will know how to deal with both things. So we need this on the basement, we need this on the roof, and now we have to decide where we place both elements, and that depends on the shafts. Okay, so here we have two shafts. Basically, we have this one, and then we have that one. So I'm going to use this shaft to connect vertically the water-cooled chiller and the cooling tower And then I'm going to use this shaft to connect the water-cooled chiller to the air handling unit. Okay. So on level -15, I'm going to place the water-cooled chiller here. And then I will use this shaft, so the cooling tower will be on the roof, close to this shaft as well. Okay, let's see what happens. Go to systems, equipment. We have to look for water-cooled chillers. This one. So let's use the smallest, the size 30 and 32. Okay, so we have a monster here. And now we have to analyze different things. Okay, so we have this monster. So we have one of these cylinders is connected to the cooling tower, and the other one is connected to the cooling coil. And again, here we have one with a drainage and the other one without a drainage. You see? I think that the one with the drainage is connected to the cooling tower. So let's do that. Okay, so I'm going to connect these two elements, the outlet and the inlet, to a cooling tower that will be on the top. And then I will have to connect this one to the air handling unit that is here. So first we have to place a cooling tower on the roof. So let's go to systems, mechanical equipment, cooling tower. Okay, so here we have cooling towers. Select the smallest one and well, place it here. But now we have to move it. If we have this on level -15, we have to change this to level 30. And now it's on the roof. And now we have to move it close to this shaft here. And as you can see, all the connections are here. So I think I will rotate this in this direction. So I will have all these connections facing the shaft here. Okay. Water-cooled chiller, a cooling tower. So first I have to connect this to the cooling tower on the top, going through the shaft. So this is the outlet. What's the outlet and what's the inlet? Okay, so that's the outlet. So we have to connect this to the inlet of the cooling tower. So where is the inlet in this cooling tower? This is out because this is drainage, and this is inlet. Okay. So now from the top view, I have to connect this inlet, throw pipe, go to the shaft. Now I have to go down, so I have to change the elevation. If this is 4, let's type -50. And then I have to go back to the mechanical room. This is too low, so I have to adjust this height. To this outlet here. And now from the top view, I have to find this, and now I can connect them. There we go. So from this one, I draw another pipe. From this one, I draw another pipe. Now top view. And here I go to the shaft, change the elevation, negative there, 50. Horizontally. Now I have to adjust the elevation of this pipe to that one. And from top view, the here and here. Okay. And yeah, every time you do something new, just check that there is no so there are no conflicts here, there are no intersections, everything goes well. Okay, so we're almost done. We only have to check that, well, we only have to connect the second part of the water-cooled chiller to the air handling unit. So let's do it. But now, well, there's no way because here we have the both inlets and outlets on the same side, so if this is good for this, because it goes directly to the shaft, in this case, it would be the other way around. So I have to I will go this, I will go up to the ceiling, and then I will go to that shaft again. So let's do it. If I'm using this one, throw pipe, I go this, then I will go up. So I change the elevation, 10. And then I'll go all the way here. And go back to the shaft. Well, there's something that catches the eye here. You see the size of this pipe. It's quite, what's the size of the pipe here? It's dimensions, it's 10 inch. Okay, so you see that the diameter is 10 inches. Well, I told you that this is, we usually have this kind of water chillers for industrial buildings, huge buildings. So that's why we have such huge pipes here. So in a small building like this, it doesn't make sense. But well, that's what we have. Okay. So probably the best option would be the air-cooled chiller, because those machines are too big for these kind of buildings. But anyway, if we had a bigger building with a bigger air handling unit and we needed this size for pipes, this is what we would be doing. So we are here again. We are within the shaft. I'm going to reduce this diameter. I'm going to make it 4. Okay, and that's a lot easier. So now I have to draw pipe. I have to go up, so change the elevation, 50, and then I go horizontally. And now I have to connect this to, I don't know what is this, out. Okay, so I have to find the in of the air handling unit on the cooling coil. So this is out and this is in. So I have to make it lower. Like here. And now row 5, like this. And okay, I think I can do it. Okay, the more pipes we have, the more difficult it gets to avoid those intersections. But I think it's good. And now from that one, I have to do the same. Row 5. Then go up, change the elevation, and then horizontal. And now I'm going to have some issues with this. See, row 5. I'm going to make it 4 inches. And adjust this between these two. Then I go up. Change the elevation to 50. And now I'm here. So this is too high. Down. And now I have to be careful because look at this. I have this horizontal pipe and I have this outlet. So what I have to do is to draw a pipe here, a very short one. Then I have to go down. So I type here only 3 feet. Whatever. Pipe. Here. Look at this. In this case, I have to make this pipe very short. Then I can go down. So I change that elevation to 3. And now I have to connect both pipes here. Okay, I can make it. Then from the top view, here, here. Okay, so now it's a question of dealing with this. This is quite difficult because the diameter of this pipe is too big. So the bigger the diameter, the more difficult to avoid intersections. But I'm getting there. So I think everything is connected now. So I have these pipes from this element. It goes to the false ceiling. And then we go up and we connect both. Finally, I should select everything and hide in view. And we have to make sure that we don't have any conflicts here. You have to double check. First, make sure that you don't have conflicts with pipe, and then activate all the elements and make sure that there is not a pipe going through a duct or something like that. Yeah.